Okay, everybody, I want to move on a little bit. We finished talking about percent composition. I want to move on to something, a little topic towards called hydrates. And hydrates are an interesting type of compound that I want to mention. And you may have come across a type of a hydrate or a type of material where, you might have find a little packet of these things within a pair of shoes, or you find it with electronic devices, or you find it with clothes, where it's kind of a little packet that says "Do not eat." And inside that package is something called a desiccating agent, or a material that absorbs water. All right. And if you probably want to absorb water from electronics and from shoes or anything enclosed to prevent moisture from growing fungus and, all the nasty things that we, don't want. So what is a hydrate? So hydrate are special types of compounds. So simply, we've kind of done these before, but typically they're ionic compounds that have water molecules attached to their structures. So if you think of this as a crystal, this crystal, and you can see there's a certain amount of water molecules that are attached to it. And there's a certain number of water molecules attached to it. Okay, a good example is, and again, this is they're attracted to it by an attractive force. It's not a true bond; it's an attractive force. Okay, and there's a certain number of them that are attached to every amount of this product, this um, substance. Okay, so for example, a good example is magnesium sulfate. Okay, and then what you'll see is you'll see this dot here, and then the number of water molecules that's attached to it. Okay, and the way we name these things, and typically they're going to be typical. Most of the time, they're ionic compounds. They're not always ionic compounds, but typically the ones you're going to see are ionic. Okay, so what we'd call this magnesium for magnesium. We'd call this sulfate for sulfate. So this is not named any different than what we normally do. Okay, what we do is we put a dot here, and this dot stands for the fact that this is added to magnesium sulfate. So that dot is attached. Okay, and then we have a name for the seven. We'll call it a prefix hepta, which means seven, and the water molecule has the name hydrate. So we would call this magnesium sulfate heptahydrate, which means magnesium sulfate with seven water molecules attached to it. Okay. Now, important to know that the dot does not mean multiplication. I know in math, we say, 2.3 is 6. However, we're not going to use that for the chemistry. In chemistry, this raised dot means plus. Okay. So you're going to add that. The water molecules are added to that. And that's probably to not confuse it with a chemical reaction. We want to show that this is attached to that. All right, so it doesn't mean multiplication. Okay, these prefixes you'll see are over here. Okay, mono meaning 1, di meaning 2, tris 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and 10, up to 10. We've seen them up to 25. You can be quite hydrated. You can also call these hydrated ionic compounds or hydrated salts. Okay, make sure that you know that water molecules are counted in with the entire formula together. Okay, and it's also important to know that if you take the hydrate, which is assumed to be the wet salt, so think this is being wet, so it's ionic compounds with water molecules attached. If you add heat to this, right, you will then dry it off. Okay, you can drive off these water molecules by breaking this attraction, by adding energy. Remember, if you add energy, this attraction is broken, water molecules will evaporate. Okay, once water molecules evaporate, so this water is lost. Once this water is lost, what's left over is called an anhydrous salt. Okay, anhydrous means dry. Okay, and the name anhydrous means without. This prefix means without. Hydrous means water. So this means without water in Latin. Okay. All right, so there's your wet and your dry. It's fine. Okay, anhydrous means without water. Dry ionic compound left after removing water by heating. Okay, and that's when it evaporates. Okay, so that's how we know. So we can heat the salt, and as that salt loses weight, we know that's drying off. All right? So that's the explanation behind what a hydrate is. Okay, and lastly, dehydration is the process by which we go ahead and we remove water. And hopefully we'll get to do this in the lab a little bit. All right? All right, so basically with hydrates, um, all right, so what if we want to name? We'll practice naming a little bit in this. Um, so say I wanted to name the formula. Let's go back. Sorry, guys. I wanted to name this formula FeCl3. Okay, dot 6H2O. Okay, what I would do is go about this. I would call this iron. Okay, now again, this three is going to go back up there. Iron has two different charges. We'll call it iron 3 chloride. Now, because we have 6 water molecules, I'm going to use hexa. So we call this hexa and then hydrate. Okay, next one would be copper, right? And then as your sulfate, again, copper has a +2 charge here. Copper has 2 different charges also. So we're going to need the Roman numeral. That's sulfate ion, right? Sulfate. And there's .5, so again, we use penta. It's pretty easy. Okay, now let's just say we want to find the formula for this. So let's go barium chloride. So, barium has a +2, chloride -2. We crisscross, we get BaCl2 dihydrate. So we're going to put a dot to show that it's attached to it. Di meaning 2, hydrate meaning water. Dihydrate. Okay, copper 2 nitrate. We know that copper is 2 plus, nitrate minus. We're going to bring the 2 down. Right, we'll have copper 2 nitrate. Don't forget to put the parentheses. Trihydrate would be 3H2O. Okay, so what we can also do is percent composition of water. And this is generally what they're going to do. You're going to be asked to do this on a number of occasions. So what is the percent composition of water? I'm being asked to do that. So I'm going to box that off with magnesium sulfate heptahydrate. So that was what we started with in the notes in the beginning. Okay, so what I want to do is this is my, right, so this is my compound. I'm going to take Mg is +2, sulfate is -2. I write my formula. I get Mg hepta meaning 7, H2O. Okay, and the first thing I want to do is find my part over a whole. If I'm doing percent composition, I want to do part, okay, over a whole times 100, and it's worth to think about what my part is. My part is going to be the 7H2O, right, over the whole hydrate, which would be MgSO4.7H2O. So I want to find my GFM of this guy, my GFM of this guy, and then go about my business. Okay, so magnesium there's only one magnesium at 24. We have sulfur is at 32. We have oxygen, there's 4 of them. We're going to times it by 16 for 64. Now, here's the important one I want you guys to do. I want you to memorize, okay, the GFM of water is always 18 grams per mole. It's for 1 mole. So it's very, very helpful to do that so that you'll have the part already in the numerator. Knowing that this is here already gives you the 7 times H2O that you need for the top of the numerator for the percent composition. Okay, so to do the percent composition, we're going to take part over a whole. We want the water over the whole hydrate all the time. Okay, and for all our calculations going forward with hydrates, please remember the whole hydrate must be on the bottom. I repeat, the whole hydrate must be on the bottom. That includes the water. All right, so we have the whole hydrate. If we add everything together, this whole thing together is going to be 246 grams per mole. So that's the total. That's the whole thing. Okay, we will put that on the bottom. Okay, and then what's nice is that if you do the chart like this, you automatically have the part that you need will go on top. So 126 divided by 246 times 100, which is now 51.2% H2O. All right, really important to know that that's the case. All right, so that's cool. All right, so any amount of this water is always 51% water. Okay, make sure you read the directions. Make sure you read what they're asking you for. Really important. Okay, so to repeat, find the GFM of the whole. Use your chart. Find out the waters together, put that as a numerator, calculate percent composition. Okay, so quick practice problem here. Let's just say I went to what is the percent water found in sodium sulfate non-hydrate? Let's do it. Sodium sulfate. Let's take sodium sulfide. I'm sorry, sodium is +1. Sulfide is -2. We will crisscross. We will get Na2S dot. Non-hydrate is 9H2O. Okay, so I want to do part over a whole times 100, where my water is the top. Okay, so let's do this. Okay, we have Na, we have S, and then we have 9 times the water. Okay, we already know what the water is. The water is 9 times 18. Okay, if we look at that really quick, we'll take 9 times 18, and we'll get 162 grams per mole. All right, and then we'll take sulfur. There is one of them times 32, which equals 32. We have 2 sodiums times 23, which is 46. Whoops, 46. So I'm going to add all together and get a grand total of 46 plus 32 plus 162. And I'm going to get 240 grams per mole as my total. All right, so let's just double check that. I'm going to take 46 plus 32, which is 78, and we'll plus 162. Okay, wait, 46 plus 32 plus 162. It's going to be 240. Okay, so we're good. All right, so now we just have to take the part over the whole. So we'll take the part over a whole. So that's going to be my water, 162, over my whole, 240, times 100. And that's pretty easy. 162 divided by 240 is going to be 67.5% water. All right, sounds good. So it says, and then, all right, so that's fine. That's our answer. So this says if 125 grams of magnesium is completely dehydrated, right? How many grams of anhydrous, how much is the dry stuff is left, right? So if we take 125 grams of the hydrate, right? And we know that that is 51.2% water, okay, we know it's 51.2% water, right? We know the rest is going to be the rest of the salt, the anhydrous. So what we could do is we could do it simply. We could take 125 grams and we can multiply that by 50.512. All right, and we'll get the grams of water, okay? So this is going to be 125 times 0.512 is going to be 64. So that means this is 64 grams of water is in there. Now we want to know how much of the dry stuff is there. So if I take the hydrate, the 125 grams of the hydrate, which is my wet, and I subtract the water from that, that'll equal the dry, right? So 125 minus 64 is going to be roughly 61 grams of anhydrous. Remember, the anhydrous is the dry salt. All right, and that should do it, okay? All right, sounds good. All right, so we can move on a little bit. All right, the last type of problem they can do is give you lab data on this. And again, we'll do this in the lab, but you want to be able to calculate percent calculation or calculate percent water and hydrate by looking at lab data, okay? So very simple. If a student collects the following data. All right, now what they'll do is they'll many times give you this particular material in a lab, of course, we weigh things. When we weigh them, we put them in a dish. And whenever we put them in a dish or a weighing boat, or sometimes they put them in a flask, or sometimes they even use something called a crucible. And a crucible is like a little container. And sometimes it even has a cover to it. Again, we'll see these in classes, but that's called a crucible. All right, and it's important to know that a crucible or an evaporating dish, which is this little dish here, we want to make sure we remove that from any of the calculations we're going to do. So this just serves to complicate things a little bit. So just make sure you remove that when you look and find your weights. Okay, really important. And really want to think about the fact that when you calculate percent water, just remember that it's always the hydrate, okay, minus the water, okay, is always equal to the dry compound. Okay, so it's easy to find the water by subtracting the wet minus the dry. Or you could think of as the wet minus the dry is always equal to water. That's another way to think about it too. So if you had a very wet towel and you wanted to find how much water is in it, you wouldn't wring it out, because if you wrung out the towel, it doesn't matter how much you squeeze the towel, you'll never get all the water out. What you want to do is dry the towel completely. So if you weigh a wet towel, get its mass, and then dry it completely, and then get its mass, then you can subtract and find the weight of the water. Okay, and then the part over whole would give you the answer. So that's pretty much what this is going for. So let's just say we have an empty dish mass. Let's say the empty dish is 5.6 grams. Okay, the evaporating dish plus the hydrate is here. So there's your hydrate in the dish. Okay, is 8.6 grams. Okay, and let's just say now that you go from this to this, which again, we're going to heat this. That's where the heating comes in. Okay, sometimes they tell you this, sometimes they don't. Okay, and now you're going to get this new anhydrous. So the hydrate is here, the anhydrous is there. Okay, so notice that this is the wet salt, this is the dry, because you heated it. Okay, you heated from here to here, you added heat. So you can see the mass gets lighter. Okay, so the question becomes, using the above data, calculate the percent water in the hydrated compound. Okay, just remember, it's part over a whole. Okay, so you need the water mass, okay, over the hydrate mass. That's going to be the formula we're going to use. All right, so you need to get this from the data times 100. Okay, so let's take a look. Now we just want the hydrate by itself. So what we're going to do is we're going to subtract the first two. So if we do this, we're going to get 5.6 grams. So the hydrate equals 8.6 grams. Subtracting the dish, which is 5.6 grams, okay, is going to equal 3 grams of hydrate, right? All I did was subtract the dish to leave the hydrate by itself. So this is going to be 3 grams there. Okay? Now we got to find the water. And there's a couple of different ways to do this. The easiest way to do it is if you subtract the dry compound, okay, and the dish from the wet compound with the dish, you subtract the dish out of there, and here the difference here is just water. Okay, so the water is going to equal 8.6 grams when it was wet minus the 8.0 when it was dry. Okay, and that would be 0.6 grams of H2O. Okay, which is exactly what we want for my formula. Okay, so this is the first step you need to do, is find your pieces. Okay, and then we'll take 0.6 grams of H2O, which is the water mass, divided by the hydrate mass of 3 grams of H2O times 100, and we get a grand total of 0.6 divided by 3, which is about 20%. So we get 20% H2O from dealing with this data. Okay, so it's important. So the big really kicker here is the fact that once you separate, once you take a wet salt, heat it to dryness, okay, the difference between those two is the water, and that's what you need. Okay, and then taking the dish from the hydrate gives you just a flat hydrate. All right, and that's it. Okay, you may get different types of data like this. Most of them are pretty much basically the same. Again, watch for the fact that this dish could be something called a crucible. Instead, sometimes they do that as well. All right, but what's the main idea? The main idea is water over the whole hydrate always. Okay, have a great day. Oh, by the way, you can finish this last problem on your own. Okay.